So yeah, alpha spectroscopy. This is the science of trying to determine the energy of alpha particle from radioisotopes. On this glow right here, we can see alpha particle have an effect on their environment. And we're trying to take advantage of that to obtain a spectrum. Now, I had my runnings with different alpha spectrometers, some good and without detectors, some bad. I wish I could afford the nicest alpha spectrometer on eBay, but I can't. But it seems like I finally came across a working device. I'd like to share the results of my experiment with you. The first thing we learned about alpha particles is that they're heavy, they carry a lot of energy, and a single piece of paper can stop them. So does the dead layer of skin on the fingers, and they're harmless as long as they stay outside the body. Because of their mass, they interact a lot with their immediate surrounding. That's why we conduct experiment in a vacuum. So the air does not interfere with the particle we're trying to detect. Now, most working alpha spectrometers have a pulse generator that allows for calibration. And this is done by simply matching the voltage generated by the pulse generator to a specific energy from a particular voltage from the incoming alpha particle, thereby creating a linear calibration curve that we can use for further analysis of unknown samples. My first obvious pick is the americium-241 from smoke detectors. Now this particular one is pretty old. It's over 20 years old. Now at first all I could get was these ugly humps, and then I figured out something about the amplification, and I could get some half decent spectrum, including this one right here. So here you can see americium-241 main peak. The secondary is drowned into the background. But what's interesting is that you can see neptunium-237 right there. Since I wasn't 100% convinced my amplification didn't have an effect on the calibration, I triple checked the neptunium-237 alpha particle, and sure enough, this energy is right there where I expected at 4.7 something. So yeah, over time, neptunium build up in americium source, and since this one is pretty old, you would expect to find a tiny amount of neptunium in it. I also had these polonium-210 source I wanted to check, and sure enough, the peak show up right there where you would expect. Now the secondary down there is somewhat of a mystery to me. I thought it was a ghost peak or another problem with the equipment, but no, after doing a bit of digging, I came across this paper, and sure enough, this is polonium-208, and sometimes it's used as a tracer. I'm not sure why, but there it is. I'm not 100% convinced on there. It's an interesting fact if it's true, but I'm pretty sure it's an artifact of my equipment and the amplification. This might just be a ghost peak. But it's undeniable that the main peak right there is at the right energy for polonium. So I just wanted to point that out. Next, I have these diodes with radium-226 in it. Now with radium, all the decay chain daughters are radioactive themselves. Most of them are alpha emitters as well. So this is it look like they all bunched up together in this area. I'm still tinkering with this equipment, but you get the idea. So this is interesting, and I'm still working on this. Obviously, the sample preparation for alpha spectroscopy is a lot more complex than gamma spectroscopy, but this is a fun project, and I'd like to continue messing with this to get better results. Anyway, I hope you enjoyed this little introduction to alpha spectroscopy. So stay tuned, and don't forget to subscribe, and I will see you on the next one. Thanks for watching.
Damn it!